Hey everybody, Chapter 1, Section 2. The title is Order of Operations and Evaluating Expressions, and it begins on page 10. You can use powers instead of having to multiply over and over again. So instead of 3 times 3 times 3 times 3, I can rewrite that using a power. A power has two parts. It has a base and it has an exponent. The base is the bottom number. That's the number that you're going to be multiplying over and over and over again. An exponent, that's the top number. It tells you the number of times that you're going to write down that base that you used. For example, this would be 2 to the third power. 2 is the base, 3 is the exponent. So I'm multiplying the number 2 because that's the base. The exponent tells me how many times to write it down. So I've written down the 2 1, 2, 3 times. Then I multiply it together. 2 times 2 times 2 gives me an answer of 8. 3 to the fifth power means I take the number 3. I write it down 5 times because that's the exponent. So I have 1, 2, 3, 4, 5 threes. And then I multiply them all together and I get 243. If I have something that's to the second power, the words to the second power means the same thing as squared. The words to the third power mean the same thing as cubed. So you'll use those later on. When you simplify a numerical expression, you'll see the word simplify a lot in your directions. When you simplify a numerical expression, you end up with a single value or a single answer. For example, example 1a, if I have the directions tell me to simplify 3 to the fourth power, okay, 3 to the fourth power means I take the number 3 and I write it down 4 times. If I multiply all those together, I get the answer is 81. So I took 3 to the fourth power and I simplified it and I came up with one answer. Another example, simplify the fraction 2/3 to the third power. Remember, the power is how many times I write down the base. In this problem, 2/3 is the base. So 2/3 to the third power means that I write down 2/3 3 times. And then I multiply all of them together. Remember, when you're multiplying fractions, you go straight across the top and straight across the bottom. So if I have these written out, if I go straight across the top, 2 times 2 is 4. 4 times 2 gives me 8 on top. 3 times 3 is 9. 9 times 3, I get 27 on the bottom. If I have a fraction for an answer, I always simplify if possible. But this one, there's nothing that I can simplify. Another example, if I simplify a decimal, so 0.5 to the third power means I write down 0.5 3 times, and I get 0.125. Just a little side idea here. Remember, if I have 2 to the third power, that does not mean 2 times 3. Okay? It's not the same thing as multiplication. Okay? Another type of problem. If there's 2 operations in a problem, which one do you do first? And then I've got the same problem here, and I've worked it out 2 different ways. On the left-hand side, I did 2 plus 3, and I got 5. And then I did 5 times 5, because this 5 just came down, and I get 25. On the right-hand side, I did 3 times 5 first, and got 15. And then I did 2 plus 15, and I got an answer of 17. The question is, one of these has to be right, and one of them has to be wrong. I can't do the same problem twice and get two different answers. The question is, which one's correct and how do you know? Well, in order to figure out which one's correct, you have to use a rule called the order of operations. And we'll talk about that on the next page. By the way, right here, this one, the correct answer is the 17. And you'll see why when we go through the list of steps. The list of steps for the order of operations, very important to put in your notes. The first step in the order of operations, you do grouping symbols first. Things like parentheses, brackets, fraction bars. Always look for those grouping symbols first. The second thing that you do is exponents. If there's any exponents in the problem, do those next. Third, multiply or divide from left to right. So if you have any multiplications or divisions, you do the one on the left first, and then you move over to the right, just like you're reading a sentence. Same thing with add and subtract. You start on the left, you go towards the right as you move along. Let's look at an example of this. Example 2a, 5 times 7 minus 4 squared divided by 2. There's lots of stuff in there. There's a multiplication, there's a subtraction, there's an exponent, there's a division. So, the first step in the order of operations was grouping symbols. Do I have any grouping symbols here in this problem? No, I don't. So I move on to number 2, and I look for exponents. Are there any exponents? Yes, there are. So I do the exponent next, and 4 squared becomes 16. Everything else stays the same. Okay, I just do one step at a time. Do I have any more exponents? No, I don't. So I move on to step 3, which is multiplication and division. Do I have any multiplication and division? Yes, I do. So I start on the left, and I do that one first. So 5 times 7 gives me 35. Do I have any more multiplications or division? Sure I do. I have 16 divided by 2, and that gives me 8. I haven't done anything with the subtraction sign yet. No more multiplication and division, so I go to the last step, which is add and subtract. I do have a subtraction left, and that gives me my answer, which is 27. Let's do another one of those. 12 minus 25 divided by 5. In this problem, remember, grouping symbols come first. I don't have any grouping symbols, though, so I can move on. Do I have any exponents? No, I don't. Third step is multiply and divide. Do I have any of those? Sure I do. I've got a division sign up there. So I do 25 divided by 5, which is 5. The rest of the problem stays the same. No more multiplication or division, so I go to add and subtract. 12 minus 5 is 7. One more of those. This one looks a little complicated. Do I have any grouping symbols? It doesn't look like it because there's no parentheses, there's no brackets. But remember, the division symbol, or the division bar, is a grouping symbol, which means I have to do everything on top first, and then I have to do everything on the bottom. So I look, do I have any exponents on top? Yes, I do. That 4 is an exponent. So I look at that first. So 4 plus 3 to the 4th power. 3 to the 4th power was 81. The rest of the problem stays the same. So I did exponent on top. On top, do I have any multiply or divide? No, I don't. So we're done with that one. Do I have any add or subtract on top? Sure I do. I've got 4 plus 81. Make myself a little more room here. And I've got 85. Bottom stays the same. So we did that one. Now we move on to the stuff that's on the bottom because we've done everything that's on the top. Do I have any exponents on the bottom? No, I don't. Do I multiply or divide on the bottom? Nope. Do I have any addition or subtraction on the bottom? Sure I do. 7 minus 2. And so I get 85 over 5. Now, is there anything I can do to simplify that? Yep, I've got a fraction, so I have to reduce if I can. 85 divided by 5 is, let me think for a second in my head, 17, I believe. Double check me on that. I hope I got that one right in my head. Okay. I don't think I did. Hey, if I can't do it in my head, I have to double check it on paper. 5 goes into 8 once. That gives me 5. 8 minus 5 is 3. Bring down the 5. 5 goes into 35 7 times. Yes, it was 17. So I just had to double check it to make sure. To evaluate, if the directions tell you to evaluate, that means plug in numbers and then solve the problem. So if I had a problem that said, evaluate 3b minus a squared, if a equals 3 and b equals 4, that means that I have to plug in 3 for a and 4 for b in my problem. So the first step is to plug those numbers in. Okay, so I took the 4 and I plugged it in there. I took the 3 and I plugged it in for a right there. Now I have to solve using the order of operations. If I look at my problem, do I have any grouping symbols? Because that comes first. No, I don't. Do I have any exponents? Sure I do. I've got 3 to the second power, and that turns into 9. No more exponents, so I go to multiplication or division. I've got 3 times 4, so that becomes 12. No more multiplication or division, so now I do add and subtraction. 12 minus 9 gives me an answer of 3. One more example here. Evaluate 2b squared minus 7a if a equals 3 and b equals 4. So I'm going to plug in 3 wherever I see an a. I'm going to plug in 4 wherever I see a b. My first step was to plug in. I plugged in the 4 and the 3 where they go. Solve using order of operations. Do I have any grouping symbols in this problem? No, I don't. Do I have any exponents? Sure I do. 4 squared turns into 16 in the next line. No more exponents, so now I look for multiplication and division. 2 times 16 is 32. 7 times 3 is 21, and I keep that subtraction sign in the middle. No more multiplication or division, so my last step is to add or subtract. 32 minus 21 gives me an answer of 11. There's one more example in this section. We'll look at example 4 tomorrow in class. Your practice problems for this section on page 13, numbers 9 through 35 odds.